Hi, and welcome to Women of COBOL, our third episode. Today, we are going to be talking with Marianne Bellotti, the author of my favorite book, Kill It with Fire. If you don't have it, you need it. And Susan Drenner, Vice President of COBOL Sales at Micro Focus. And we're going to be talking about modernizing COBOL applications. So let's start with some quick introductions. Marianne, tell us a little bit about yourself.
Yeah. Hi, everybody. My name is Marianne Bellotti. I am an author, an engineering manager, and software engineer. I've been doing the type of work that I do for about 20 years, and I tend to focus on large, complex systems, maintaining them, operating them, different failure modes on them, which for a large period of time, I was working in the federal government, involved a lot of COBOL, but isn't necessarily exclusive to the language of COBOL.
I love that point. We are going to circle back to that one, I think. Susan, tell us a little bit about yourself.
Sure thing. I'm Susan Drenner. As you mentioned, Misty, I'm the Vice President of Sales at Micro Focus for our COBOL solutions, and that covers North America, so Canada plus the United States. I've been at Micro Focus since 1996, always in what we consider the kernel of technology of this company, which is our COBOL development and deployment solutions. I did take 5 years off in the early 2000s. I stayed home with our 3 small children, but came back in 2008 and really have been enjoying supporting our customers, our partnerships, and really representing what I think are some of the best products in the legacy modernization space. So that's what I do.
So I see a whole lot of intersection between the two of you because, Susan, you're selling solutions and you're helping customers with the tools and things that Micro Focus has to offer. And Marianne, for a long time, you were a receiver of that technology. So the whole premise of Women of COBOL is that we give women from various aspects of COBOL in this world a chance to chat with each other. So how about if we dive right into why modernize COBOL applications rather than just getting rid of it altogether and starting over?
Do you want me to start with it?
Yeah, you guys just jump in. We're doing this.
I mean, the thing that I always come back to is what can you actually run? Like, what can you actually operate and keep up and running, and for the efficiency and effectiveness of your business, right? For some organizations, that answer might be just sticking with COBOL because you don't actually have the expertise in the other alternative languages. So you would end up doing a lot of outsourcing. You'd end up doing a lot of contract work, which would leave you with a system that you don't know how to run or maintain, which is much, much worse than the numeric age of your system. But for other organizations, that picture is going to look different. So the number one priority has to be, what can we operate? What can we maintain? And what technology is right for us, rather than like COBOL or not COBOL.
And I would add to that, I completely agree. You know, what we see with our customers primarily is we can provide them a modernization path that is low risk because they aren't ripping and replacing or rewriting to some newer language. It's high reward because they are currently working with technology and applications that they have spent years customizing to their necessary industry differentials. And it allows them over time to make incremental steps in modernization versus a big bang effect, which again brings up the concept of risk and cost. Right. We've seen many of those sorts of projects get launched and fail, some taking years to fail. And, you know, that's obviously an expensive proposition for any organization. And our thoughts really are, you know, work with what you know, work with what you have, keep your industry differentials, don't throw out what you've spent years building. And we have a path for you that can support that, that journey. So, you know, I don't want to turn this into a commercial for Micro Focus so much, but we do spend an awful lot of time supporting COBOL as a language and investing in development solutions around it. So I feel somewhat like I represent the custodian of COBOL in a distributed environment moving forward, which is a great place to be these days.
Yeah, this idea of fails really has me really interested, because I was presenting at a conference recently, and I had several people come up to me and say, I don't know why you're talking about moving COBOL applications to another platform. Back in 1987, there was this bank that tried to do this and it failed spectacularly. You know, what are those failures, and what are you seeing about why is it different today, or is it different today? Marianne, you know, you worked a lot in government, which is famous for failures.
Yeah.
So let's start there.
No one does large, complex software failure the way the federal government does large software failure. I mean, I think what's interesting about software is that, so everybody knows Moore's law, which is this idea that over time hardware gets cheaper and smaller. But there is a different corresponding unnamed rule, which is that software gets more and more complex and expensive. And so a lot of times when we go into a system and we look at the COBOL, we're just looking at one part of a much, much larger system of things built on top of the COBOL, right? And what's very interesting to me as somebody who has like primarily a background in social science before I became a software engineer is that the human process was there first, and then we digitized the human process, and then the human process adapted to the digitalization, and then the digitalization adapted to the new human process. And there's just sort of this feedback loop, right? And so a lot of times what dooms software projects to failure, this sort of rip and replace model, is incorrectly assuming that the software that existed that was built in, let's say, the 60s is an accurate specification of what the system is actually doing, right? And so the rip and replace model really breaks down when you're not coming to it honestly, when you think to yourself, like, everything has been solved. We have figured this all out. All we have to do is just take the code and rewrite it in another language. If you're going to go that route, you really need to invest in it, in rethinking exactly what this system is trying to do, like what the conditions and context around what it's trying to do are, and then like using that agile methodology of like, what is the minimum viable thing that we can like establish is valuable to the company, and work your way up. But a lot of times, because it is an operational system, people are impatient with it. And it's not glamorous or sexy to rebuild a system from the ground up. It's glamorous and sexy to do something new. And so they don't want to do that. They don't want to invest the time and effort in like really approaching it that way. And the irony of it is it ends up costing them way more money and way more time than it would have if they'd actually just decided to sort of use a more user research, agile-based approach to thinking about the problem.
Right.
I think we should name that unnamed law the Bellotti law. How do we feel about that? Can we vote?
I mean, you suggested it. I will not turn down the honor.
I think of the people who have a voice right this moment, it's unanimous.
Okay, good.
So we'll do that. Susan, what are the things that you see for those failed projects? I mean,
well,
we haven't had any failed projects.
Oh gosh, no, never. The one that most recently comes to mind and probably got the largest press was when we were all heading into COVID shutdown, and the unemployment system of the state of New Jersey hit the skids. I don't know if you all recall this, but the governor of the state, I think, stated that the problem was COBOL. COBOL is old and lousy, and COBOL failed, and people can't get their unemployment claims because of COBOL. And what we really find is, you know, anybody with any knowledge of software and infrastructure, et cetera, will know that it's typically not the language that's the problem, right? It's the infrastructure and the possible delayed maintenance and enhancement of the volume of processing needs necessary to run an unemployment system that gets hit with 100-fold claims to a normal situation, right? We did work actually with various states. I won't get into whether it's New Jersey or not New Jersey, but many states had a lot of unemployment claim processing issues. And frankly, when we speak with our state customers, their issues are really around infrastructure, cost reduction, and security. And if you put those three things together, we can help modernize those environments. COBOL can live in those environments and bring value today. It's really typically not a language issue. So I guess I'm getting a little off track on your question about failures, but we've seen them, we've supported the recovery from them, and in some cases, we've got partners that specialize in sort of rescue missions into areas where they can get somebody back on track.
I thought you were going to say we have partners that specialize in failed projects.
Well, they do that, yeah.
In recovery missions.
There's a really important point that's just been made in that the problems that people observe and attribute to COBOL are broadly found in a wide variety of languages, if not all languages, right? Like a lot of, it's almost never COBOL in and of itself that just breaks one day. It breaks because someone attempted to change something and didn't understand the full impacts of the system. And why is that? Well, you didn't have any documentation. You didn't have any form of integration testing to see like what is the expected behavior and like what is the outcome of this change. And that's very common in older COBOL programs because that wasn't the convention, that wasn't the standard in engineering at the time. That was a thing we learned through hard experience that we should always do. But at the same time, you can find applications that were written yesterday that all of those things are true for. It has very little to do with the language.
Agreed.
I love your website, Marianne, with the quote that says, secretly all software development is legacy modernization. Because the second it goes into production, it's instantly legacy.
Right.
And I do remember the New Jersey thing because it made me very angry. I like to say, and it was my birthday, and I like to say that you can write garbage in any programming language. Yeah. It doesn't have to be COBOL to be a bad application. And I actually wrote to a tech reporter, if you're going to write about COBOL, you might want to do 5 minutes of research first. I was so mad that.
Oh, Misty, you can't take it personally if you're in the world of COBOL. I mean, come on. We are the butt of many.
Oh, I know. I've been in this space for 30 years. I know. So the guy wrote back, everything about mainframe screams Sith. So I changed my Twitter name to Darth Misty, the mainframe Sith. And that has been the best move I've ever made in my life because it gave me a platform to speak the truth, which I've been doing ever since.
Yeah.
That was a good day for me. So there are a lot of misconceptions about COBOL, and we can save that for another Women of COBOL. But what I'd really like to talk to you guys about, because you have so much experience, how do those misconceptions lead to bad business decisions? What does your experience, give us some examples without the names of misconceptions leading to bad decisions?
I mean, I think what's underestimated is the internal sales pitch, right? If you are a director of a division or even just an engineer within a corporate environment, you need to sell the things you want prioritized up the chain of command. There's an infinite number of things that an organization could invest in a quarter in terms of money and people, resources, and intention. And so a lot of times, software engineers who do in fact know better will use these myths to sort of like create that sales pitch of like, I need this money to go here on our maintenance efforts. Oh, there's COBOL over here. That's a thing I can scare everybody to death over. And I'll just go like, there's COBOL here. There's COBOL. Right. We need to get rid of it immediately. So I feel like a lot of technology decisions are ultimately a matter of like internal lowercase people politics, right? The things that you have to do to build momentum and persuade people that your approach and the stuff you want to accomplish is the right thing to accomplish. And it ends up being, in some cases, an own goal, because you, by simplifying it and making it easier to sell and communicate up the chain of command, you've also created an inaccurate picture of like what success really looks like.
Yeah.
I love that. I want to give you an example if I can jump in here. We just did an interview with AG Insurance that just did a massive mainframe modernization project. And we asked, what are your top 3 reasons why it was successful? And one of his top reasons was that he launched an internal advocate campaign. And it was a marketing campaign internally to get everyone on board with the project. And he said, you've got to get everybody in agreement and moving on it. And I think he called it a modernization advocate program or something like that inside the company.
Yeah. It's like a thing I teach my engineers all the time when they're thinking about how they scope their project. You need to budget a period of time for evangelism, whether that is sitting, going one-on-one, pairing with other engineers, showing them how to use the thing you just built, or socializing it higher up, or whoever the audience is. You cannot just expect like the field of dreams scenario. You've built it. Now everyone understands and appreciates the value of it, right? You have to really put the time and effort into thinking about that.
That's really interesting. And it kind of talks to the bias that exists that you have to overcome before you even get to, building out your project plan. I was speaking with one of our partners today. He's a small independent software shop that writes an application that deals with land management. It's sold into counties and states. And, we were talking because he's got a couple challenges on his plate, but he said, one of the crazier ones is if they think it's COBOL, they won't take my meeting, right?
Wow.
We don't want COBOL. Oh, no, that's not going to work for us. And he says, well, you haven't even seen my software in action. You don't know what it does. And if he can get them past that immediate bias, he typically gets the sale. His business is expanding. He's got, what's really about a 20-plus-year-old environment that he's continued to modernize and sell into our state governments for land management. And his biggest inhibitor is that 5-letter word. They're just not sure what to do with that when they realize that even the database is COBOL. It's not even SQL. So.
Wow. Oh, I need to pause for 1 second because the sun is setting and you can't see my face anymore. So
you're glowing.
Well, that's better. Okay. So yeah, it's a really interesting topic about these social dynamics that go on, and it makes so much sense to me that sadly that a customer wouldn't even take a meeting if they think the application's written in COBOL, when that's just a construction material.
Yeah.
Right.
Yeah.
And it has absolutely nothing to do with how the program operates. But I'm reminded, Marianne, of, I was introduced to you before this book. You wrote an article about how COBOL actually has an advantage when it comes to financial calculations. Without getting super, super technical, do you have a way of summarizing that article?
Yeah, it was basically a discussion of fixed versus floating point calculations, and how you can do the math right on either system, but you have to be prepared. You have to know you're using that system and prepared for the consequences of moving from one to the other. Because when we think about things in fixed point, there are a different set of concerns when we're doing these kind of financial calculations than there are with a floating point technical system. And what is particularly relevant for financial systems is that if you get it wrong, you end up with a rounding error. But you end up with a rounding error that's like something like, I don't know, like 1/8 of a penny, say, which may seem like completely insignificant. Except that financial calculations feed other financial calculations, which feed other financial calculations. So like these tiny, tiny, tiny little losses in accuracy eventually cascade up to like really serious outcomes, really incorrect results. So I was kind of exploring the space here and like what people's awareness of this issue were and their preparations, and then some of the interesting theories that I had been exposed to around overall performance. Because in a lot of quote unquote modern programming languages, there are the libraries to do fixed point arithmetic, but they're not considered a standard library, which means you have to import it. And the whole dynamics of like how imports actually work in language systems, and like the little tiny nanoseconds of transaction time you might use every time you use a library, and like scaling that up. Can you see a performance impact? And it was an interesting sort of like thought experiment to sort of inject these type of scenarios into the conversation, particularly for an audience that is used to just going, well, you know, obviously we'll just put it in Java and everything will be fine, right? To sort of say like, not necessarily. You can do it, but you have to know what you're getting into.
Yeah, I would agree, and I would say, you know, as somewhat an evangelist of the language, we don't recommend you use COBOL for everything. You're not writing your front end in COBOL, but you're utilizing it for what it does best. And you hit one, which is math calculations. I think you also mentioned performance and processing. I mean, it's kind of what it does best. Is it's just a massive engine that's going to crank out a really accurate response in a really rapid pace. So seems great to me.
I would really love for there to be a wider forum and conversation with the people like the engineer you mentioned before, Misty, like people who are writing new things in COBOL. Yeah. I find that fascinating. I would really love to know, like, what is it, the thing that they built? Like, why is COBOL the right language for it? And like, what has been their experience? And like, what's their maintenance strategy over time, right? Because I know that they're out there, and I know that it's more than like little toy or joke projects. Like I also know that there's like a web framework in COBOL, but I think that's mainly meant as like a joke, right? And so it'd be interesting to sort of hear the perspective from people who are writing, not maintaining old stuff in COBOL, but writing new stuff in COBOL.
Right.
Idea for future episode of Women in COBOL.
You know, I haven't seen a lot of new development, and I'm wondering. I've never ever asked anyone this question before, but I think you ladies are the right people to ask. Clearly, there's bias. COBOL isn't even on the list when they're trying to figure out what language to write a new application in. So we know that bias is there. If we could wave a magic wand and that bias disappeared, what are those use cases where you think COBOL would be the right programming language for brand new development?
I mean, I would look at it for anything that involved bulk transactions. That's what it was developed for, and that's really where a core competency of it still lies.
Bulk transactions. That's really interesting. Because I had somebody once theorize that the financial calculations underneath cryptocurrency and would be an interesting use case. What do you think about that one?
I don't know, but I just that would be amazing to watch. I have so many opinions about what's going on in the cryptocurrency space.
That's not this webinar.
Yeah, like, this is not the right forum for all my opinions about like cryptocurrency, snake oil, or like Savior. But I mean, like the space is really interesting from sort of a technical point of view, and like something like that would just be that would be a really incredibly insightful conversation, I think. I doubt it will catch on because the Venn diagram of people who are interested in COBOL and like this type of
cryptocurrency interlock.
Yeah, there's very little space between those two.
There's very little space, but you know, you never know where the future's going because
we're
doing things like this.
Internet that likes both, and that's it.
If it makes them money or saves them money, if that if that calculation that goes out 8 digits, and you know, maybe this will catch them. They'll say, "Hey."
Yeah, spoken like a fantastic salesperson. So if we can show how it makes them money, they will be interested.
Right. Absolutely.
Very interesting to sort of get a sense of what is the amount of COBOL that's not on a mainframe, and it's also not an intermediate step in getting rid of the COBOL entirely. So I've seen a bunch of COBOL on mainframes. I've seen a bunch of COBOL in the cloud, usually running on an emulator of a mainframe. preparing to like get to a different future state. I don't know that I've seen a great amount of COBOL running in like a cloud environment or even like a local a personal computer style application just for being COBOL, right?
Susan, you have a perspective on that.
I do. I don't have percentages. That's a great question. I should probably know the answer to, but sure, I would still assume the majority of COBOL is sitting in a mainframe or in a cloud-based mainframe environment, right? But the customers I support are typically distributed COBOL environments, and many of those applications were written prescriptively to be distributed. So, we have over 350 software application providers that chose to write their application originally in COBOL, and they're running it in Windows and Linux, and they always were. So it's when they sell a new end user their application, they're selling more COBOL every time they do it. So it is actually growing. I'm assuming not at the same rapid pace as maybe some of the larger financial processing environments are growing, but we see an awful lot of distributed COBOL, which is where Micro Focus plays. We aren't typically on the mainframe. We are what happens when you come off the mainframe. So,
yeah. Well, we did do a COBOL survey. We partnered with Vance and Bourne that did a COBOL survey, and they did an estimate of how much COBOL is out there, and they found 800 billion lines of code in production.
Yeah.
It's an estimate, right? It's a range, but still, no matter how you look at it, that's significantly more than the last time this survey was done, which I think is like 10 years ago.
I remember 300 billion. I mean, so
and the last one, yeah. It's a lot, and the vast majority are planning to update those COBOL applications. I'm trying to see. There was a survey that said what platforms they're on, and it's in the survey. There's a webinar. You can watch it and you can see that if you're really curious. I should have it memorized since it's kind of my job, but I don't remember.
And honestly, going back to, the 80s and 90s, a lot of our commercial accounts wrote distributed COBOL applications. And you might wonder, why did they do that? Well, they had the skills in-house. They were replicating maybe a expensive centralized environment that they now needed to create smaller distributed versions of. So they went with what they knew. They went with skills in-house and basically an application structure they'd already done once before. So it's sort of a roll it again process that built a lot of distributed applications that were written for distributed environments, but maybe were mimicking the original, 1.0 version of this application that still lives and breathes in the mainframe. So,
yeah, I think there is still quite a bit out there that's not on mainframes, and I know that moving these applications to cloud is accelerating. I saw a recent survey run by Accenture.
yeah.
It was stunning to me. In February of 2021, they asked something like 100 large, really banks world, what they plan to do with their mainframe applications. So that's not necessarily COBOL, but probably a large share of it is. And 42% said that they're going to move more than half of them to the cloud within 5 years. Excuse me. Just 9 months later, that number went to 84%.
I was about to correct you because I was saying it's not 42, it's 80. So yes, yeah, I heard that.
In November, it was 84%. You know, and it's like, that is a massive turnaround in attitudes. And my theory is, and there was an article that Forbes wrote about this results. And they conjecture that the reason for that change is that these large banks had already moved their, let's say, operations to the cloud or customer support, and they saw the advantages of it, and that convinced them that they should move everything else. My theory is that the pandemic really highlighted the costs of not modernizing those applications. And And I will say you can modernize COBOL in place on a mainframe. And I think there's plenty of instances where that is appropriate and the best choice. But once you're looking at modernizing it and and by modernizing, I don't mean using new technology, right? I mean Marianne's definition, which we've talked about on other webinars over and over again, which is making sure that it's satisfied. I'm phrasing it differently now, Marianne. Making sure the application is meeting your modern needs. So right. I can keep the word modern in there. So she says returning to operational excellence, but regardless, it's about it doing what it needs to do.
Right.
And once you open it up and you start to look at what do I need to do to make this application meet my modern needs, do what it needs to do now, all options are on the table. So turning it into microservices on your mainframe, or moving to DevOps on your mainframe, or moving it to cloud. So you have, if that application needs very dynamic scale out capabilities, that's harder to deliver in the mainframe, then that's the right choice for you. And I think that's what's really going on right now is they realize the vulnerabilities that they had all along.
Do you think also, Misty, the pandemic de-risked it all? In other words, the art of the possible became the art of the reality, where companies might have been hesitant to be the first ones to risk their mission critical environments by doing something so dramatic as moving it to a cloud. The pandemic threw them in there, and all of a sudden it seems, hey, not only is this not risky, it's working and it's saving me money. And my goodness, why didn't I do this sooner?
You know what? I didn't think about that one, but that's a really interesting point. It could be success breeds success, you know?
Right.
You see failure after failure and you don't want to follow that path. But when you start seeing success after success, which we're seeing right now,
right?
AG Insurance, I just said, Santander, Kmart, you know, some really big organizations have moved their core services exactly as it was on the mainframe, moving it on to the cloud, and they've been able to perform. Qantas, big companies are doing this in a lot of different industries, and maybe that's what's accelerating this. It's interesting. Yeah. So, Marianne, we're conjecturing, and I know that's one of the things you love to do. Do you have any theories?
Well, so the thing I keep coming back to is that a lot of times you can have a system that is fundamentally broken but doesn't appear that way, because within the boundaries of what you're asking it to do, it does the right thing all the time. But when you change the context, like now requiring everyone to work remotely from home because they can't come into the office, then suddenly it's incapable of adapting, and it starts to very quickly break down when people try to do the same functions that they had. So it's not a huge surprise to me that the theory that you're putting out there, that perhaps the pandemic accelerated some of these projects and the trend towards moving in these directions, because the pandemic actually accelerated a lot of things that businesses were sort of digging their feet in. Like, I had been running distributed teams for like years and years before. And it became a thing I then had to teach my colleagues how to do. And they were actually quite surprised that there was an entire knowledge base on like how you successfully run a distributed team and like not go crazy, right? Because everything that they did in terms of the hiring they had to do, the way they had to manage their business, was working. You know, it was working fine. So why change, right? And then suddenly it wasn't working fine, and they have to change. So I think it's probably a similar dynamic where a lot of companies were sort of just happy with the way things were going with their data centers and maybe their, you know, mainframes. And then suddenly when they had to sort of completely change the way they operated, they started to see some of the maintenance costs that they had accrued by ignoring it and just assuming that it worked. And that helped reprioritize everything.
Yeah. I'm loving this conversation, by the way. I'm just going to take a moment to appreciate the two of you, because, you know, I'm in this space, all right, all day, pretty much every day of the week, right? Even when I'm not working, I'm still reading about COBOL and mainframes. And both of you keep bringing up points I hadn't thought of or read before. We're we're inventing new space here. And the whole point of Women of COBOL is to highlight you for what you know. And you're proving the point right now. You guys rock. That's all I wanted to say. I love you both.
Thank you. Thank you, Misty. And I'll just say, having lived in the world of COBOL for many years, I don't tend to get that sort of accolade. I've seen people spit out their Starbucks coffee when I tell them what I do for a living. So I really appreciate it.
You know, Marianne, you have something in your book that I have referred to over and over again, and that is a little bit of history of programming languages and how there's the 3 different paths and why these more complex languages tend to be more popular. Do you want to, you know, it was fascinating to me. Do you want to explain a little bit of that?
Yeah, so basically what I believe about the growth of programming languages is that you can sort of sort them into family trees or lineages depending on who their target audience was. When you look at things like COBOL and Fortran, they are very clearly geared towards the business user, right? Let's build, like, they have like whole reason to exist. Their mission statement from the very beginning was like, let's write a programming language that people who are not computer people can write code in. And Fortran, it was like math and sciences, and in COBOL, it was business analysts. And I'll open that up to the everyday enterprise and its users versus something like C, which was quite clearly the audience was computer scientists who were interested in sort of the theoretical space around like hardware and software and like the mathematical concepts behind computation, and is written like when you learn the language of the mathematics that they were thinking about, a lot of the syntax of these languages suddenly comes to life, right? It isn't just like an arbitrary choice. It makes perfect sense. And I think progressively you sort of see the languages kind of come into that kind of lineage. So the thing that I've always said is that, like, it doesn't really make a lot of sense to me why when people want to get rid of their COBOL, they immediately gravitate towards a language like Java. Because if you think about the languages that exist today and are popular and well supported and have lots of programmers working in them who are doing the sort of things that COBOL traditionally does around data processing, the language that really is the heir apparent to a lot of the work that would have gone to COBOL is Python, right? Like when we talk about we need to process a huge amount of data and do these kind of analysis and calculations, like most software engineers would reach immediately for Python, not Java. But the type of software engineer who maybe like 30, 40 years ago, or like 20, even 20 years ago, became a COBOL engineer is now becoming a Java engineer. So it's really like it's about that perspective and that use case and the types of tools that you're exposed to. That's like, I find it really interesting how that influences what people are drawn to and what they identify as the correct solution. So I spent a little time sort of breaking that down in much more detail.
Yeah. That's really interesting. I tried to convince my son, who's a computer geek. He's teaching himself programming. Tried to convince him to look at COBOL, and his choice of programming language was 100% made by what his friends were learning.
Sure.
So I think there's a lot of social peer pressure. And we fool ourselves into thinking that these choices are made logically and based on technical basis. But, you know, especially after reading your book, everyone read her book, I came away with, wow, I never realized how much of our business decisions, our technical decisions, are actually based on emotion, social pressures, history.
What you know.
Yeah.
Yeah, you are going to apply the tool you know. I'm kind of curious, having heard your thoughts on the provenance of these languages, you know, where they came from and you know, COBOL being a business language and Fortran being a math and engineering language, et cetera. How would you define a modern language? What in your mind makes something a modern language?
Well, so that's a thing that I actually take quite, I'm usually on the other side of that question, right? Because the scenario that I find often and is the most entertaining for me is, now Java is considered an old language. It's a legacy language. Get rid of that old Java and move on to Python, right? And that's generally where
write that in COBOL for you. Don't worry.
And so, yeah. and that's funny because if you actually look at the timeline of those two languages, Java and Python is older than Java. But most people are surprised by that fact, right? Because the perception of these languages is Python is modern, Java is old and enterprisey. And a lot of it goes back to what we were saying before, the people who work in those kind of languages and the situations that we associate with those kind of languages. And since Python has made such huge inroads in data science and AI and machine learning, people naturally associate it with like more cutting edge. If I had to define what a modern software language is, I'd probably look at like what the trends are in the research. Like right now, what's going on in the programming language community is a lot around typing. It's a lot around formal reasoning. And so the kind of languages, I don't know that I'd ever describe a language as particularly modern versus others. But if you put a gun to my head and said like, you must pick a modern language, I would look at things like Haskell, like Elixir, like things that are trying to leverage a lot of this return to Boolean logic and formal methods and verification within the language itself. Maybe even like if we wanted to go for a list, maybe even looking into like the closure world and things like that. And so that's really what I would, if I had to make a definition for it, I would make it about how these concepts that we're seeing in research papers are starting to like come and be embraced as first-class citizens within those languages.
I call that postmodern.
I mean, some of this stuff, it's more like abstract expressionist language.
Yes.
Like I've stared at some like TLA plus until my eyes bleed and still not really sure what all the symbols mean in a row. So like, yeah I mean, my postmodern language might be the.
I mean, it's somewhat of a loaded question on my part because I try to, when I hear customers worry about COBOL and COBOL's old and we got to get rid of COBOL, I try to redefine what's modern is what's running, what's working, what your hammer might be the oldest tool in your toolbox, but it works really well for certain things, right? You're not going to use it for every job that you've got, but if it's working and it's interrelating with the other things around it in a way that supports your future modernization needs, it's modern. That's right. Kind of that's the structure I would think about it. What's lifting the workload for you? What's helping you? What's bringing you reductions in costs? Those things are modern.
I think that's a great point. Nobody ever complains that their hairdryer isn't modern enough, right? It's like, does it work or doesn't it work? And I think a lot of that has to do with the fact that people are really used to computers breaking. They're really used to like their software not working. And so the oldness of or newness of the software gives them a feeling of implicit security in an inherent uncertain space. If software were more reliable, no one would care how old it was, right?
Right. Agreed.
So, all right, I'm looking at the clock here and I want to make sure that we end on a fun note. So I have a crazy idea. I should have warned you in advance, but I believe you guys are going to be able to hang with me. You guys both have so much experience, just so much. I'm sure you have some amazing stories that if I sat down with the bar with you after a conference, you would blow my mind with some crazy, crazy stories. So with the names removed.
Sorry, they're all classified.
tell a crazy story that would blow the minds of our audience. Anybody got one?
I mean, I'm in sales, Misty. Do you want a crazy sales story?
Sure. Something about COBOL, attitudes about COBOL, failed projects, successful projects only because somebody rode their bicycle in the middle of the night, still in their pajamas. I don't know, something.
I mean, I'll tell a story that's kind of an embarrassing personal one that I haven't told anybody really.
Oh, yes. Oh,
Back
I'm
in the
loving
day
it.
when I was 6 months pregnant and I was calling on a large financial institution in the World Trade Towers, and I had finally lined up a development team of about 60, primarily men, to hear our pitch about analysis tools. It was a product called Revolve, and we were selling into their shop so that they could better understand their application and landscape, their application environment, how it maps, dependencies, all that stuff. And we finally got the room together. And I decided that day to put on a nice red yoke sweater with a black body to it. And I paired it with some black slacks. And we got in front of this whole group and we made the pitch of the century. It was great. There was so much to know. We showed them their own software applications running within our tool and how it did things and all this. At the very end, the big guy in the back of the room, the boss of all the team, does this. And he says, "Live long and prosper." And I looked down at my outfit and I'm literally dressed like a Star Trek character. Oh my God. And that was it. That was the end of the sale. They didn't buy it. They probably should have benefited from it. They are no longer in business.
That's a good moral of the story. Don't make fun of a woman's outfit.
Yeah.
Thank you for recognizing the Star Wars reference, dude. And you might want to take care of your COBOL, otherwise you're not going to be financially stable.
You can cut that whole story out if it's not appropriate, but it cracked me up at the time. And yeah,
I think it's great. I think it's great. Do you have a story for us, Marianne?
So my story is not my story. It actually comes from my little brother, who was in the Navy for a number of years as a nuclear engineer. So therefore, it's not about COBOL, because I do not believe there are any submarines that are currently running on COBOL. But he was telling me a story about how they had this one particular valve that kept breaking on the submarine. And they would replace it, and it'd be good for a couple of days, and it would break again, and then they would replace it again, and it'd be good for a couple of days, and it would break again. And so finally one day, it was like chicken wing night at the mess hall. So they took the bones from the chicken wings, and they built kind of this voodoo doll and put it next to the valve, and then it didn't break anymore after that. And they were like, "Oh, cool." So they're like, "This is great." They're going about their day. Like a week or two later, a junior officer comes in and looks at the space and goes, "What is all this garbage? There's like literally chicken bones just hanging around. Get rid of all of that. Clean up this space. This is unacceptable," right? And so it's very diligent Navy men. They're like, "Yes, sir." And they go and they clean up the space and they throw out the chicken bones. And the next day the valve breaks. And so the commanding officer comes in and he says, "I thought we had this licked. What's going on?" And they explain, "Well, we built this thing out of chicken bones and put it there and the valve stopped breaking. And then the junior officer maybe made us get rid of it. And then the valve broke again." And the commanding officer stares at them for a minute and goes, "We'll put back the chicken bones then." The moral of the story is trust process that works. Don't overthink it.
Don't overthink it. I think that's probably, it's not a COBOL story, but in some ways it is, right? Because the COBOL works, and why are we over engineering things, right? You might end up breaking it. Well, boy, this was fun. Any parting words for our participants, people that are watching Women of COBOL here? No.
Well, that's a hard one. Yeah. What would I say? I would say there's opportunity, and this is an expanding space. It's be excited. What we thought was going to be sort of the sunset of an environment that many people have built 40-year careers on is launching into a whole nother realm. It's going cloud, and that brings on a whole lot of different needs from the technologists that support this. So I would just be very encouraged that if you're building a career in this space, consider security, consider, knowing your languages that wrap around legacy, become a legacy modernist, figure out ways that you can use the skills you've brought with you to support companies that are still running legacy systems. And I think you're going to find a lot of opportunity.
I think you're right on that.
I'd agree with that point. I'd say I've never gone wrong by just pursuing things that were interesting to me. I think trying to engineer your career for some sort of long-lasting impact based on like what other people think good technology isn't the way to go. You got to optimize for your learning and your engagement with the technology. So
I love that we ended on some career advice. So I'll throw in mine that's related to what you're both saying, and that is the most valuable people in any company are the ones that not only understand their little piece, but they understand how their piece connects to the things near it and related. So I never told students to be a COBOL programmer. I tell them to add it to their quiver so that they can bridge the old and the new and be that person in the company that can bring things together and help them figure out how to go forward. Great. I love this ending. Fun stories, great advice. Thank you so much for your time today. I love talking to both of you. So it was really exciting for me to talk to two of my favorite women at once. Thank you very much. And I hope the audience had as much fun as I did.
Good stuff. Thank you both.